Hello and welcome everybody to Kubernetes online masterclass series. Good morning, good afternoon, and good evening, depending on where you are joining from. We had 1,000+ registrants for today's class, and we are expecting several hundred of you to join. Usually it happens that way. People join from all over the world, so thank you for joining. If you are in Asia or Europe, pretty late for you guys. This is a series that we started about 2 months ago. We run it not every week, but almost every week, and we pick interesting topics. I'm going to go over that. The session is about an hour long, and then after that we have a Q&A. So I'll go over some of those mechanics as well. But just to get started, we have covered various topics in the past, like migrating existing applications with Kubernetes, Prometheus. We're going to talk about Prometheus support sometime. We're going to talk about how to troubleshoot. We are going to talk about today how to run databases. I'll speak about it. We talked about security a few times, and we talked about just building a Kubernetes strategy in your enterprise. So if you are interested, here is a list of what's upcoming, and you can go to our masterclass page. Just search for Kubernetes masterclass in Rancher, and you will find the past recordings, as well as all the sessions that we are planning in the coming weeks, coming months. Okay, but today we are talking about working with databases on Kubernetes, and deploying a database in production on Kubernetes is a fairly complicated issue. Starting from, we are going to cover a lot of it. We are going to cover starting from what it means and how to deal with it, to how to really solve it. And we have somebody from Portworx, an engineer, Michael Ferranti, who's going to walk us through that. He has his slides, and he has a demo as well. Now, before I get started, we also get questions about Kubernetes. In general, we believe that there are no bad questions. So if you do have questions about Kubernetes and how to get started with Kubernetes, we do run another training every Thursday. It's at rancher.com/training as an intro training to Kubernetes. So that's also something interesting if you want to go and check it out. But on to our presenters. Today we have Michael Ferranti, as I mentioned. He's VP of Product Marketing. Michael has been an engineer for a very long time, and he has been in this space for quite a while. He has been working with containers and storage actually since 2014, and he was a part of a team that launched Flocker, the first open source project to tackle persistent storage for containers. And now he runs both product and product management and product marketing at Portworx, and he works with enterprises everywhere. And their primary goal is to make data-rich applications successful in containers. So if you are wondering, I already have an application, I've figured out how the containers work, I'm learning more and more about Kubernetes, and then the last stop that I haven't figured out yet is how to work with databases and containers, you have come to the right session, and you have the right person, one of the best people in the world to talk about this topic. So I hope it will be helpful. And my name is Ankur Agarwal. I'm head of product management here at Rancher Labs. My job is to define new capabilities and products for our users. Prior to joining Rancher, I built and ran Kubeship.io, which was an accelerator focused on container delivery. I've been in DevOps and cloud computing space for over a decade, and I've built several cloud products for companies like VMware, Mercury, and now, of course, for Rancher. While Michael walks you through databases in containers, I am going to be answering questions on chat in the background. So please feel free to send us any questions. And remember, there are no bad questions. We strongly believe in that. So we have had questions about what is Kubernetes and how do I convince my managers to sign up with Kubernetes, and all these questions. And we are happy to answer as many of them as possible. That's the purpose of being here. We welcome every question. If they are on topic, great. Michael will answer as many of them as possible. We will, in fact, stay back and try to answer as many as possible. And if they're generally about Kubernetes, we're happy to answer that. We get a ton of questions about Rancher. What is Rancher? We try not to cover those because this is very on topic. But if there are, we will be happy to answer those as well. And that's about it. One of the basic questions we get is this session being recorded, and can I get slides? Absolutely. Just go search for our Kubernetes masterclass, and then you should definitely be able to find these recordings online. They are out on page. They get posted to our YouTube. So there are multiple ways in which you can get it. And Michael, with that, I'm going to hand over the session to you, and please take it away.
Okay, great. Thank you very much, Ankar. I am going to share my screen, everyone. Okay, here we go. Let's get started. I'm very excited to be here. I'm not going to kind of rehash the intro content that Ankar shared. I think that's a great introduction and exactly what we're going to focus on today. So let me make my screen full screen. All right. So, I won't kind of spend a whole lot of time on the bio. The one thing that I'll share is I kind of, maybe it's a claim to internet fame, but I've been doing stateful containers since before it was cool, and many would argue that it's still not cool. So, it's kind of an arcane topic, but I think one that is really, really important. And just one anecdote. To share how far the ecosystem has come with regard to this topic. When I left my stable job to join a startup who had the crazy idea to enable persistent storage for containers and stateful containers like databases to run on Docker. As kind of a data nerd, I wanted to get a lot of feedback from individual engineers who were trying to solve these problems at their SaaS companies within San Francisco. That was kind of the ecosystem that I came from. And I asked people, so you're running Docker. What are you doing with it? What about your databases? You're an email API for developers, or you're, a metrics engine. What are you doing about your state? And they said, oh, well, we're pretty much universal. We are not running that in containers, right? That's of course data is important, but we wouldn't touch our data with a container, but with a 10-foot pole, as they say. And I think I could have taken that as a recommendation not to join this startup focused on data management for containers, but instead I took it as a challenge. And I think the ecosystem itself has taken that as a challenge. I look at it as this ecosystem is a group of people who really believes in a new way to build and run applications, and that's based on microservices. Containers are a packaging engine, and it leverages new technologies like Kubernetes to automate the entire stack up and down. And I think my view is that if we believe that that's the right way to build applications, then what would the world have been like if we had never made the leap to be able to run a data service in a virtual machine, right? If we believed in the benefits of virtualization as a better way to run the enterprise data center, but we said, okay, but we have to stop when it comes to databases. How much smaller would the impact of virtualization have been? I would argue that really we wouldn't even be talking about it today. It would have been so much as a blip. Cloud never would have been invented. Amazon never would have made it easy for any team anywhere to easily get infrastructure. That was only because that technology was able to extend itself to data-rich applications. And I think we're at a very similar part of the journey today when it comes to containers. Not every problem is solved yet. And it's not evident and easy to solve a lot of other problems. You have to do some research, you have to do some experimentation, but I think we're on our path. And hopefully what I'll be able to share today are some of the insights that I've gained over a 5-year journey, focused exclusively, frankly, on running data-rich applications in containers. Some things that I know that you will have to solve, and I solve it for you because I don't understand the context of your business. I don't understand the context of your system, but I can point to some high-level things that you'll have to solve. I'll share with you an approach that you could take. I'll show a demo of running MySQL on Rancher Kubernetes engine, and then we'll take some questions. And I'd like to keep it pretty informal, and take all of this as the opinion of one person, but one person who has spoken to hundreds of customers about their approaches. And my attempt here is to consolidate it down into something that I think that you can take away, and will make it easier for you to kind of start your stateful container journey or kind of take it to the next level. So, I'll start my presentation with the acknowledgement that it's still not uncommon for people to say, whoa, 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 hold up. When we start to talk about containers and database, realize we're on thin ice. We need to approach it very, very carefully. This tweet from Kelsey Hightower was just a couple days ago, and I was preparing my slide. This came up, and I thought, hey, I'm going to include that in my presentation. So I actually agree with what Kelsey is saying in this tweet. You absolutely should exercise extreme caution when running stateful workloads on Kubernetes. The one thing that I don't agree with is really kind of, I think, the underlying sentiment that if it's not stateful, then we don't have to exercise extreme caution. And I think that makes stateful services seem special instead of just different. Stateful services are different. There are different problems that you have to solve when the workload is stateful, like a database. But there are hard problems that you have to solve when an application is stateless as well, right? If you are in charge of Uber or Lyft's geolocation service, right? That's a stateless application. But I would posit you need to exercise extreme caution with building and running and deploying that system because it's mission critical. If you are in charge of a streaming engine within Netflix, then I would posit that you need to exercise extreme caution, even though that's a stateless service. And so I think a better kind of axes for caution versus no caution is kind of important mission critical production application or not, right? If it's not important, then you don't need to exercise extreme caution if it's stateless or stateful, right? It's a POC, it's a demo environment. We're just trying to get our hands dirty. But the moment you step to kind of mission critical, and I think the game changes for all types of applications. And so our reply to Kelsey was, you're right, but you need to exercise that caution for any mission critical application. And the second part of the sentence is, for stateful apps, that means solving things that you don't need to solve for stateless applications. Data security, disaster recovery, high availability, multi-cloud. Like all of these things, they don't say that, with the exception of data security, they don't say the word data in them. But if you have to have something to be highly available, right, a container can spin up in milliseconds. HA is only relevant within the context of a rich application. Multi-cloud is only complicated not only complicated, but more complicated when you have data. You need to be available and staged in those multiple environments. So all of this is to say, stateful containers are different. They're not special. You still have to exercise caution for all parts of your application, but I think it's a healthy conversation to have, and that's what I want to focus on today. Since this is a masterclass, I wanted to put my professor hat on and share a little bit of a timeline of stateful containers. I think this sets the stage for some important topics, and I think some important reasons why I think the ecosystem still has some work to do. It really starts with, and by the way, as the title indicates, this is incomplete, right? So please ask questions about things that are left off, but realize that I consciously left most things I could have put on this timeline off in order to share what I think is kind of the meta arc of going from inability to run stateful services on containers all the way to lots of success stories happening today. And the first part of that journey really started with the launch of Docker in March 2013, was followed about a year later with the launch of Kubernetes. I had already started at a company called Cluster HQ, which is the founders of the Flocker project. Kubernetes was launched. It was actually working on a presentation about the container ecosystem, and there was kind of a running joke office that basically there was a new project being launched every day, and as I was working on my presentation, Kubernetes launched. I remembered exactly where I was when I read about it on Hacker News. And both Docker and Kubernetes in those early days were really focused on stateless applications. I mean, it was just pure and simple as that. The primitives for stateful applications did not exist in those tools when they launched. Flocker was launched in July of 2014. And again, this is kind of the first open source project that was really focused exclusively on the ability to run stateful services in containers. And That only came in July of 2014, and it was a year before Docker in 1.8 came with the notion of a volume plugin, the ability to easily kind of take an existing volume on a host and bind mount it into a container. That was a year after Flocker came around, and another year before Kubernetes introduced the notion of in-tree drivers, which to kind of cover over a lot of details, you could think about as being a volume plugin model like Docker, but for Kubernetes that introduced some additional primitives like PVs and PVCs and things like that. So then we had to go about a year and a half before a new model for interacting with storage systems was introduced into Kubernetes, and this was called CSI. CSI solved a problem of the in-tree drivers. Kind of an update to them required updating the entire Kubernetes code base. It made it very hard for storage providers to get their plugin into Kubernetes to make it available to their users. It was kind of a testing nightmare. There were a lot of combinations depending on the scheduler used and the underlying container engine that you used. If you were on DCOS or if you were on Docker or if you were on Kubernetes, CSI solved that by making a single standard interface called Container Storage Interface that made it really easy to build drivers and as a user to pick and run a driver that was compatible with any scheduler system, including Kubernetes. And then it was about a year again before that was productionized, before it was GA. And that happened at kind of the end of our timeline, which is this CNS Day at KubeCon, December 2018 in Seattle. And what is CNS Day? Well, this was a group of 8 cloud native storage and data management companies that came together evangelize the category of container native storage. And so Upbound, the team behind the Rook project was there, Maya Data, the team behind OpenEBS was there, Portworx was there, Kasten, Diamante, I'm gonna leave somebody off, Red Hat was there. The point being that there was so much work that happened in the preceding 5 years, so many success stories that we felt as an ecosystem that it was necessary to come together and really educate the broader ecosystem who hadn't spent as much time working with databases and containers about the success stories of companies like T-People and others who are really seeing a lot of benefits by being able to get the same agility that they get for the rest of their applications for their databases on Kubernetes. And I put that as kind of an endpoint of this timeline to suggest that kind of, going from a time when the idea of running a database container was pilloried by pretty much all of the thought leaders in the ecosystem to one in which, we had a 500-person waiting list for this day, really shows just how much progress has been made. And yet there are still a lot of problems to solve. And so if I were to take a step back and say, what is the state right now of the ability to run stateful services on Kubernetes, I would say that it's very good. It's not perfect yet, but it's getting there. And thanks to a large part of a very broad ecosystem of technology providers. So if it's not there yet, why not? Well, I think that it's worth spending a couple of minutes looking at why containers are different than VMs. And you've heard this presentation before, and so there's a lot of things that I'm going to leave off. For instance, around density, around packaging. Those are clearly differences, but they don't bear as much on our discussion of stateful services on Kubernetes. I think the 4 that are really, really important to understand is, one, simply how dynamic containers are. If you're picking Kubernetes for the right reason, it's because your application or applications are of sufficient complexity that you need to outsource your ops to a computer, right? That computer is called Kubernetes. So if you're picking Kubernetes for the right reason, you expect Kubernetes to make scheduling decisions for you. You expect Kubernetes to move your applications around. You don't want to be in a position of having to interject and say, oh, no, don't make that decision, right? You don't want to get woken up at 3 o'clock in the morning so that you can say, no, don't put that over here. That application is special. It needs to stay. No, you're outsourcing that to Kubernetes. And this is what's scary about putting your data services in there. Because if the underlying primitives aren't set up correctly, your pods move somewhere, your data's not there, users experience downtime, right? The point being, containers are dynamic. You've outsourced your ops. If you have pets, they're going to be lost. That's just a fact. The reason they're going to be lost is because machines in a container environment, individual hosts, are no longer the proper unit of analysis. You can't count on processes that are based on machines to do things like data security, backup, DR, high availability, provisioning. They just simply don't work. I mean, Gartner has some insights into this that I'm going to share in the next slide around some particular ways in which machines kind of fall down in this model. The next big difference is that container environments are heavily multi-tenant, right? So what does that even mean? How is something heavily multi-tenant? Well, this isn't so much a function of containers from a technology perspective, so much as a function of how application and platform teams are using containers. So first of all, if you're running in the cloud, you're already in a multi-tenant environment, right? You are sharing that EC2 instance, or that host, excuse me, with multiple users. There are multiple EC2 instances on a single host, and multiple companies can be renting those VMs. So that's one layer of multi-tenancy. Kubernetes and containers put a second layer of multi-tenancy on top of that. Now, not only am I in a multi-tenant environment at the VM level, I'm also in a multi-tenant environment at the container level. So, if host-based management capabilities were no longer sufficient with VMs, right? There are some things that I have to do at the virtual level I can no longer do at the physical host level. We just multiply that out in terms of complexity when we add on. Now it's no longer even the individual virtual host is no longer sufficient. I have to provide access controls, for instance, at the pod level, not even at the host level. Complexity is multiplied. And the last thing is that, the great Star Wars quote, with great power comes great responsibility. Well, individual devs in a Kubernetes environment have been radically empowered for speed, right? It is so easy right now to build, run, and deploy an application in a Kubernetes environment. I mean, we have customers who are saying, it used to take 6 weeks to get an application environment because we had to put a ticket in for the hardware. Then we had to put a ticket in to get an OS provision on top of it, and a VM, and all of these things which were ticket-based. Now that same team, they can onboard an application as long as they're packaging their app in containers, then they can onboard that application same day to their Kubernetes platform. That is enormously empowering to the individual developer, but it also increases risks. So you need systematic ways to make sure that your corporate level policies are not violated when an individual developer who might not be up to date on security or compliance restrictions or governance restrictions or various data regulations to build and run applications that are data rich, right? That's a risk area that comes with containers, because the speed is so much greater, right? Before, you had to go through ticketing systems and someone was bound to raise a red flag before it got through to production. A lot of those barriers are now removed with containers, and so you need to think about other ways to solve that. Okay, so this gets us to a point where we can ask the question, why is it so hard to run databases in containers, right? We've seen kind of the evolution and the really positive evolution of the primitives coming online for doing things like persistent volumes and persistent volume claims. But we've seen that containers are different from VMs. And I think we can put these two together to say, why are in March 2019, why is this still a challenging topic? Well, there are two things that need to work together in order to successfully run a database in a container. When that application is an important enterprise application. And what I mean by that is, it's not something trivial where if it goes away, we just say oops and move on, right? This is an important enterprise application. When that's the case, you really need two things. You need storage for containers, and that's your persistence layer that was enabled first by Docker Volume plugins, by Kubernetes entry drivers, and now via Kubernetes. It provides the primitives like PVs, PVCs, etc. You also need data management for applications. And here I'm referring to things like data security, right? That can't be controlled at the host level, right? I can't just make sure that if you don't have access, if you have access to that host, maybe you shouldn't have access to some applications running on that host, right? A multi-tenant security. I need disaster recovery that is enabled at the application level. I'm running a 10 node Cassandra ring on Kubernetes, and I need to back that thing up, right? Well, those pods are running all over my cluster. Where exactly are they running? Well, I can get pods and I can look, but as I'm looking to see where the 10 are running, I maybe have one pod that's being relocated to another host. I may have multiple pods running on a single host, other pods running on different hosts. So taking an application consistent backup of that distributed database is complicated. Even if I have persistent storage for containers, I have a volume for each of those pods, but taking an app consistent snapshot is a challenge. And so to summarize, I would say as an ecosystem, most of the focus for the last 5 years has been on enabling storage for containers. That's what Docker volume drivers and entry drivers and CSI are about, storage for containers. Data management, on the other hand, has not been ignored, but it's been underrepresented. And underrepresenting data management for applications means that business requirements get left behind. And I would argue when Kelsey Hightower says we need to exercise extreme caution when running databases and containers, what he's talking about is, are your business requirements met by the technologies that you're using in order to run those stateful containers? Let me explain what I mean there. So this is very, very common. Pretty every single one of our customers starts here, right? They're building an application platform using Kubernetes. That platform is going to be multi-tenant. It's going to have multiple users. The reason it's going to be multi-cloud, the reason they're doing that is because they need their business to move faster, right? They're in a highly competitive environment. They just need to be able to build, run an application faster than their competitors. They need to be able to automate. They want to optimize their infrastructure, maybe in terms of cost savings. That's why they're choosing Kubernetes. And within their enterprise, we see them being successful with Kubernetes for about 10% of the total application portfolio of that enterprise. And when I say enterprise, I'm saying ExxonMobil, I'm saying Pfizer Pharmaceutical, I'm saying Coca-Cola, right? These are companies with thousands and thousands of applications, some of which are never going to go to containers ever, right? A bank is not going to rewrite their mainframe application to run in a container, and they shouldn't. They're not going to start running their Exchange server in a container, and they shouldn't. Their SAP or Oracle financial applications, these are not applications that need the automation and scale associated with Kubernetes. So let's call that 20% of enterprise apps never ever move. There's just not a story for it. On the other hand, there are those cloud native applications that were built from the ground up for microservices for container packaging. We see about 10% of enterprise applications, and that number might even be a little bit high, fitting well into that model today. So there's 70% of enterprise apps that don't fall into the pure cloud native or never going to be cloud native applications, 70%. And as teams try to onboard those applications onto their Kubernetes platform, we see them falling down for reasons like you see here. And this is what I mean by those Kubernetes alone not being able to meet business requirements. This is why stateful applications are different, is because they have requirements that are not well met by Kubernetes today. For instance, I have sensitive user data, right? I need to make sure that someone with access to a namespace that shouldn't have access to a particular data doesn't have access to it, right? This just makes sense within a multi-tenant environment. I need to be able to control who has access to what. And yet Kubernetes doesn't support those level of access controls within a namespace. I might have an application with strict performance SLAs, right? I need to not just specify the amount of CPU and memory, but I also need to be able to manage I/O through to that application. Make sure that as my I/O is decreasing to an application, that I can move it to another host, or I can move other apps that are on that host away to provide more resources. I might have strict DR protocols, right? I'm pointing out that the individual business units within an organization have requirements that go above and beyond the ability to package an application as a container. The packaging an application as a container, providing a persistent volume, are for the most part solved problems today. It's these higher level business requirements that are more challenging to meet, and I would argue are kind of the next frontier in the ecosystem's ability to have enterprises be successful with containers. If we can solve these business requirements for these mission critical apps, I think that we're going to start to see that number of apps that run on Kubernetes within an enterprise go from 15 to 20 to 25 and well over 50% of apps that are able to run on Kubernetes. I think other people's research has borne this out. The New Stack published a story in right around KubeCon, where they said that 80% of enterprises list data management, persistent storage, and disaster recovery as top barriers limiting container adoption. And Gartner has shared similar metrics. So they recently released a report, and I've got a link for you to be able to download that on the next slide, called the INO Leaders Guide to Storage for Containerized Workloads. This just came out in January. INO stands for Infrastructure and Operations. So this is Gartner's look at kind of how enterprise IT should be thinking about storage for containerized workloads. And they point out a number of things. I think the most important for this slide is simply that existing machine-based approaches to solving these business requirements that I've talked about are insufficient. You have to look at container granular ways or container native ways to solve those business requirements. The business requirements aren't going away, right? We're not going to be able to build a business unit. Hey, data security is not important. Hey, you don't need it. Disaster recovery is hard to do on Kubernetes, and so you just can't do that if you run on Kubernetes. You have to sacrifice DR if you want to get the agility of Kubernetes. Like, you can say that, but that app team is never going to run on your platform. And I think that is both limiting for the business itself, right? That's just a limitation that's unnecessary. And also, I think it's a limitation to all of us as people who enable the success of Kubernetes within our organization, right? This is kind of, as they would say, if we want a rallying cry, this is our time. This is the time in which we can marry the fast way to get to market and the right way to run an application. I mean, if we can't handle those business requirements, then the business units are not going to want to run on our platform, and thus we're limiting our own impact within our organizations. So just to go a little bit deeper, in the way you can download this report for free at portworx.com/Gartner. We've licensed the report and make it available to the entire ecosystem. Gartner has kind of three ways, and I really do encourage you to read the whole report because my summary is basically, you can see it is pulled from the recommendation section, but that's 1 page out of 10. They go into a pretty impressive amount of detail about the ecosystem and mention a lot of different approaches to this. And the other thing I'll say is just that I come to this conversation with the perspective working at Portworx, but this report really talks about the ecosystem. It mentions Storage OS, and it mentions EBS, and it mentions NetApp, and it mentions a lot of different storage solutions. And so you can pick the right one for your workload. But I think the important thing is, regardless of the solution that you pick, the contours of the problem are not going to go away. So for instance, Gartner has a couple of things. One is that you should select vendors that are closely integrated with Kubernetes and support standard interfaces. That translates into make sure your solution supports CSI, right? CSI is the new way of interacting with between storage primitives and the scheduler. Make sure that your solution supports CSI. You also, though, need to choose storage solutions that are aligned with microservice architecture principles and adhere to the requirement of container native data services. What does that mean? That means don't expect that your host-based DR program or your host-based data security program is going to work in a containerized environment. There's an impedance mismatch between my ability to control what goes at a host level and my ability to control what goes on at a container granular level. If you have a business requirement, you have to make sure that you can support that business requirement for a pod or a group of pods or a namespace. If you're looking at a storage solution for Kubernetes and your vendor says we support disaster recovery, ask the question: can I have a backup policy for a pod or a Kubernetes namespace, or do I have to do all of that at a host-based level? Right? You have those are the types of questions that you have to ask. And I can't tell you the answer to that question. You have to understand your business requirements and just know the right questions to ask. I think that's the most powerful thing that I can share with you. And the third is select products closely aligned with dev workflows tools. What does this mean? Well, I think there's a good example, and we alluded to it earlier, which is that many developer teams are now running distributed applications within Kubernetes. So I might be running a 10 node enter ring or 5 Kafka brokers or something to that extent, right? Many enterprise storage systems for a long time have given us a notion of consistency groups, that I can snapshot a set of machines at the same time and take an application consistent backup. Okay. So I want to do the same thing, but I want to do it for my pods. Well, that's actually a much different problem, because now my machine-based tooling no longer works. First, I can have multiple pods running on the same machine. I can have pods spread across multiple machines. I need a different level of access. I need to be able to control at the pod level. You need to make sure that those types of workflows are well supported through your storage vendor. So again, this is Gartner's take on it. It's not a take. We've licensed the report. Encourage you to check it out at portworx.com/Gartner. You can download it for free. I think it's a lot of really, really good insights. And hopefully it'll help you formulate some of those questions so that as you approach how to solve those business requirements, you'll be better suited to kind of pick the right solution. Okay, so I want to just do a quick time check. Okay, 37. So I'm gonna go through this next part a little bit quickly because I want to make sure we get to a demo, and I'm going to make sure we get to questions. So I've spoken a lot about the differences between containers and VMs. So I want to give you some questions that you, as an architect, as an engineer, need to be able to answer for your business and your application before you run stateful services on containers. And again, there are multiple ways to solve these problems. I'm not here to tell you which way to choose. I'm here to highlight the issues that regardless of which you choose, you're still going to have to solve either explicitly or implicitly. So for instance, why can't you simply, connect your Kubernetes environment to an existing storage array that you already have in your data center? And I would even extend this to cloud-based storage like Amazon EBS or Google Persistent Disk or Azure Disk. Why can't I just use that? Well, we just answered that. That tooling is typically machine-based, not container granular. So if you have multiple pods running on an EBS volume, well, now how control that volume. And if you don't have multiple pods running per EBS volume, then you're going to be limited to about 25 volumes per host, which means your density suffers. So you're going to need to think about other ways to solve those problems. So how do you allocate infrastructure to your users? So you're building this dynamic system. And app 1, app 2, okay, theoretically tickets, to provision a server, to provision some storage. But when n equals 100 or n equals 1,000, how do you statically define that and not be in a situation where you're using containers, but you still have to file tickets in order to provision infrastructure? A special case of provisioning is scaling. How do you do that, right? Do you want to have admins that are on call when your cluster is at 80% capacity, or do you want to be able to automate through a combination of storage tooling, container management tooling, in order to be able to scale your infrastructure no matter how many applications are running? How do you deal with day 2 failures, right? I think Kelsey, as someone who I believe has worn a pager in a past life, is very cognizant that, when the database goes down, that's a bad situation, right? And that can happen for a number of reasons. Storage drives can fail, a server can fail. I might need to update my software. Maybe there's a CVE, and I have to update my entire Kubernetes cluster. How are you going to deal with that when you have stateful applications? How are you going to, I've already talked about this, how are you going to ensure application consistency for distributed applications, right? I want to back up my Cassandra database, or I want to back up Kafka brokers. Well, I can't use machine-based snapshots for that. And even if I did do individual machine-based snapshots, still not going to be application consistent. That my database is going to be corrupted when I try to spin it up. You're going to need to solve that. You're going to need to solve high availability across availability zones. Amazon doesn't do this out of the box for you. If you're using the native Amazon EBS driver and Kubernetes fails your pods over between AZs, you're out of luck. EBS is only available with a single availability zone. At best, you're going to have to do something like snapshot your database to an S3 object store in the other availability zone, then pull it out. And that's not exactly HA. Maybe that's a sufficient backup story, but that's certainly not HA. How do you manage application performance where you might have multiple deployments all running on the same hosts with different SLAs, right? You make sure that if you got in this multi-tenant environment, if you have one with a critical SLA and one with kind of a lower SLA, that the one does not impinge on the other. You need to make, you need to be able to secure your customers' data between namespaces. The list goes on and on and on. Okay, so the next set of slides are, I'm going to spend about max of 5 more minutes, and then I'm going to go to a demo, and then we'll take questions. So the next set of slides are related to how Portworx thinks about the world, and I just want to caveat this with, or preface this with saying, I'm not suggesting that we are the only way to solve this problem. What I do suggest with the next set of slides is that there's a useful way to think about functionality such that you are able to solve these problems. And you don't have to use the Portworx platform in all of its components in order to solve the problem. You can use a Ceph or you can use a Gluster, as long as you're also thinking about the other components in the stack. That's the important capability. So when we think, okay, all of the problems, and I feel like I've just spent a lot of time just basically being a downer on you and saying you have to solve this, you have to solve this, you have to solve this. How do you actually do it? What I would argue is you need to think about building functionality in several different buckets. We happen to package these buckets together and call it the Portworx platform, but even if you don't use Portworx, you still need to solve the same sets of capabilities. The first is persistence. We talked about this at the very beginning, and this is what I argued is becoming more and more of a solved problem across the ecosystem. And frankly, we've been doing this for about 5 years now, starting with the introduction of Docker volume drivers in 2014. Here, you need persistent storage that's container granular, that's scalable, that's tunable, and that's highly available, all at the container granular level, not at machine level. That is extremely important, and that's the core insight that Gartner shares in their I&O guide, right? That's the foundation, but that doesn't solve everything. You also have to think about monitoring and metrics, right? Regardless of what solution you use, you need to have Prometheus set up. You need to have Grafana dashboards. You need to understand what is my IO profile for this particular application, what application is available, what application is unavailable. You need to think about, from a monitoring perspective, the tooling such that you can take automated responses. You need to think about security, authentication, authorization, encryption, ownership of data at a container granular level. Again, that container granular is really, really important. You don't want to be a situation where any user with access to your namespace has access to all of the data volumes living on that namespace. That is a compliant officer's nightmare, right? And I don't want you to be in a position where you that becomes a gotcha, because I think a lot of people are surprised by that. But Kubernetes doesn't provide the data security within a single namespace capabilities. You have to think about, how do you authenticate users, authorize them based on ownership models, and then encrypt all of your data with keys that only you control. You need to think of application and data migrations, right? There have been a number of critical CVEs that have come about that our friends at Rancher have done a fantastic job working with the ecosystem to identify and then rectify. What that's meant is a lot of applications being moved to new upgraded Kubernetes clusters. How do you do that when you're running MongoDB or Elasticsearch? You have to think about that and make it seamless to migrate both applications, all of my controllers, all of my YAML files, and the data. App consistent snapshots, backups to cloud, copy data management for debugging test purposes. You need to think about how you solve that, as well as disaster recovery. So zero RPO failover. As a for instance, if I'm running in Amazon in Northern Virginia, and I want to be able to have a DR site within Azure in Northern Virginia, how can I fail over between what we call those federated clusters with a RPO or a recovery point objective of 0? That means I'm willing to accept 0 data loss. How do you do that? How do you fail over further across the wide area network between, say, Azure East and Azure West? How do you do disaster recovery, again, for apps and data, and do all of this in a container granular way? If you can think about your business requirements in these terms, again, not in terms of the Portworx product set, but in terms of container granular storage, container granular data security, container granular disaster recovery, you can start to put together a solution that's going to work for your applications. And with that, I wanted to share a demo of how to run MySQL on RKE, and then I want to turn it over to some questions. So just to make sure that there are no snafus, I'm showing this as a recorded demo. This is available on our YouTube. You can just Google HA-SQL on Rancher at RKE. And you'll find it. You can watch it at your leisure, but I'll walk through it here. So what I'm doing is I am going to first install through the Rancher catalog, so you can see it there. I'm going to be walked through basically a configuration engine that takes all of the different environment and variables for your application, and basically creates a YAML file that will deploy Portworx as a daemon set. So I'm going to specify a couple of different options in terms of versions. There are defaults, and you can always pick latest if you want to do that. So I'm going to update the version of Portworx to install, as well as the version of Stork. Stork is an operator, for an open source operator for Kubernetes that handles volume placement and ensures hyperconvergence. So your pods are always on the same host as your data. I'm just going to update my cluster name, and then I'm going to launch Portworx. This part takes about 20 seconds, so I'm just going to fast forward in the video until that is deployed. So now Portworx is deployed, and now I'm actually going to launch MySQL through the Rancher catalog. So I'm going to go to MySQL. I'm going to give my database a name. I'm going to choose a namespace to deploy it to. I'm going to create a MySQL password so I can log in once on the server side. I'm going to specify a storage class. Portworx provides default storage classes for your application, and the storage class is going to define things like backup policy, encryption policy, etc., so that kind of for developers who have access to your system but might not be security experts, you can automatically apply encryption policies, snapshot and backup policies, DR policies, without the individual developer even having to know that. So now I'm just going to get into a shell within the Rancher UI. I am going to see that my 3-node cluster is up and running, and I'm going to show you how I can log into MySQL, add some data. And then eventually we are going to kill that MySQL pod and see that it's rescheduled to another host with its data intact, and I'm going to show you some kind of day 2 operations as well. Okay, so I'm just showing that I've got a volume at where varlib MySQL is mounted. That's got about 8 gigabytes of available storage. Now I'm going to log into MySQL. I'm going to add some data to my database. Okay, so now I have some data in my database. I have some company names and phone numbers. Now what I'm going to do is I am going to cordon off the host that pod is running on. I'm going to kill the pod, and I'm going to see that Kubernetes automatically reschedules it to another host. So I can see the pod is running on -60, a node -60, which I'm going to cordon. I can see that server was cordoned. Then I deleted my pod. That went really quickly, but now you can see that one pod is terminating and another is initializing. That's terminating is on -60, and the one that's running is now on -251. I'll just keep 251 in the back of your mind in a second. So now what I'm going to do is I'm actually going to so I'm going to show you a day 2 storage operation. One of the things that a lot of our customers said that they wanted was the ability to kind of resize their data volumes on the fly. So I'm going to show you how to do that by just updating my PVC. So here I've got my PVC that defines my storage capabilities. And you can see I've got 80 gigabytes. I'm just going to resize that to 800. My application is still running. There's not going to be any downtime. I've simply updated my PVC, and you can see that now Portworx is showing 800 gigabytes of capacity for that application volume. I can also see that my pod is running on node 251, showing that that the reschedule happened, that I still have my data, and you can see that I've got about 800 gigabytes of storage available there. So that's kind of a whirlwind. I'm going to stop there, though, because I want to make sure that we leave plenty of time for questions. I hope this has been helpful. I am going to stop sharing my screen, and we can turn it over for questions.
Hi, Michael. There are many questions. Some of them are I assigned a few of those to you, and some of these are related to your licensing. I'm going to ignore those for now. Let's try to answer the technical questions that came.
Yep.
That'll be.
Are the ones that are signed would be the ones that are showing up in my question queue?
They would be, and I haven't assigned you all of them, so I will start doing it now.
Okay.
Go ahead with the ones that are already in your.
Okay. Okay. So the first question is, how can I manage database upgrades and migrations in a safe manner? Excuse me. I deploy the next version of my application that requires a database schema migration. What tools and how can you help me do that? So that's a great question. So the first thing that you need to do is be able to have a copy of your data. So this is called copy data management. In there, what you're going to want to do is take a snapshot of your database, your data volume, excuse me. Then you are going to want to spin up a new pod and use that data volume. Now we have a new version of your database, say the latest version of MongoDB. You can run your CI tests, and you can make sure that everything is copacetic. If so, then you can upgrade basically or promote that new version of your database to prod. Portworx actually has some capabilities around blue-green deployments for this that automate a lot of those steps. But regardless of the system that you use, you're going to want to snapshot the underlying data volume, spin up a new version of your application pod mounted to that volume, run your CI tests, and then if everything is working well, you can switch your load balancer over to that new application. Okay, looking at the next question. I don't see which ones are assigned to me.
No problem. Let me ask you a few. There's a question about what is the best database to use with Kubernetes. I mean, and people are asking, like, is it MariaDB? Is it something else? So, that's an interesting question. Is it Oracle? Like, what do you guys recommend?
Yeah, I mean, so that's a question without an answer because the best database is always related to your application requirements. I can tell you the top 5 most common that we see are Cassandra, Kafka, MySQL, Postgres, and Elasticsearch. We see a lot less MongoDB than other data services, and I don't really have an opinion on why that is.
Yep.
But you know, once you've solved persistence and data management at a container granular level, and there I mean data security, backup and recovery, things like that. Really, Couchbase or CockroachDB or Postgres or MySQL, none of them are better or worse for Kubernetes. It's kind of a binary. Either you can solve those problems, in which case it's okay to run on Kubernetes, or you can't, in which case it's not. There's kind of not a magical database that is easier, quote unquote, to run on Kubernetes because you need to solve all of the same underlying problems.
Okay. There's a question about Kubernetes operators and how they help or do not help in running stateful workloads on Kubernetes. So the question is, what works and what doesn't work if you use the operators?
Yeah. So the thing to understand about operators is one, they're a continuation of the philosophy behind Kubernetes, which is that computers are better at making operational decisions than people are. So that's kind of at a macro level. That's what operators do. They make automated decisions. The thing you have to understand about operators, and the reason I can't answer that question categorically, is because you have to understand what is the scope of that operator. Right now, for instance, we work with Couchbase as a Portworx partner, and they have a operator for Couchbase. Really, really great operator that handles the installation and upgrade of Couchbase itself, as well as kind of resyncing a Couchbase worker into a Couchbase cluster. Those are all necessary components of running Couchbase on Kubernetes. But what that operator does not do is, for instance, manage the underlying data that's associated with it. So, for instance, if I have a 3-node Couchbase cluster and one of the nodes goes away, the Couchbase operator can instruct Kubernetes to bring up another node, but it's not going to bring back up the data. There are other operators that would ensure that. For instance, Stork that I mentioned earlier, Stork will actually tell Kubernetes if there's a backup or a copy of that data somewhere else in the cluster. It will tell Kubernetes where it is and where to schedule. So I think the thing about operators is A, not assuming that they're magic. 2, understanding what their scope of operational management is, and then mapping that to your business requirements. You never get away from understanding the business requirements, and if you and what you're trying to accomplish, what the operator itself does, then you'll be able to either leverage those operators, excuse me, for all of the things that they do, or say, you know what, the operator gets me so far, but then I need to build something else to get to the finish line. And you'll just know that coming in. I have seen some people assume that operators, because they think about it at kind of a marketing level, like, oh, an operator for Couchbase, it must do everything that Couchbase DBA would do. But that's not the case, at least initially.
Okay, well, thank you. We are almost out of time. Actually, it's about 11 right now, but I will give you one more question. I think it's very relevant to what you were saying just now about backups. The question really is very simple. How do you handle backups with Portworx? And if you take a snapshot, you snapshotting of the volume, will that do the work, or do you need to do something more?
Yeah, so that's a great question. So with Portworx, we have a notion of app and data backup, and we think that this is really important because you saw in my demo that my PVC had been updated. I actually updated the PVC to go from 80 gigabytes of data to 800. Now, that PVC is not the actual data. It's an object within Kubernetes, but that object defines my desired state of my Kubernetes cluster. So if I'm making changes to my Kubernetes objects as well as my data, you need to be able to back up both the objects and the data. I think that is that when you think about it that way, it turns out that Kubernetes is not actually as stateless as you thought it was, in the sense that the objects themselves are mutable. I can update my PVCs, I can update my my storage classes, I can update my controllers. And so what Portworx does is we say an application is made up of controllers, objects, and data. And when I need to back them up, I need to back them both up. And so what we do is we basically give you the ability to pair two Kubernetes clusters together. So let's running in an RKE cluster on Amazon and on-prem. You can pair those clusters together. You define a migration YAML file that says, this is my source cluster, this is my destination cluster. I want to include all my Kubernetes objects in this backup. You can basically kubectl apply that YAML spec that defines the migration. Portworx copies all the data over and all of the objects, and there's a flag that you can use in that YAML file, which is said start pods in new location. And if that's the case, the pods will actually come up in order once all of the data has been migrated. And you can also do this in a continuous manner. So you can actually back up across the WAN, say from Amazon US East to Amazon US West in a continuous manner. So you can, when you deploy your pod, you can basically deploy a backup schedule, and Portworx will pair those clusters together and say every 5 minutes or every 15 minutes, we'll back up your data and your Kubernetes objects to the new cluster, such that if you ever need to spin up the application in the new environment, it's already ready to go. And I'm happy that's kind of a quick overview since we're running low on time, but I'm happy to share more with you about that later.
Okay, that was helpful. And I think we will end it here. There were a lot of questions about what Rancher can do and you know, a little bit about Kubernetes as well. So I brought up this page. We do have a blog, rancher.com/blog. You can just go to rancher.com, also look at our docs/docs. And then, as I said before, if you're just starting out with Kubernetes, then we do run a starter training called rancher.com/training. So you can join that. We do that every Thursday, and Adrian Goins runs it for us. He's very experienced. He has been with us for a long time. He can answer a lot of questions about Kubernetes as well. And Michael, thank you very much for joining from Portworx. This was definitely a great session to be here, and I learned a lot. I'm hoping that our audience learned a lot too.
Yeah, right, thank you so much. And I forgot to mention one thing. If anybody wanted to know more about running specific cases on RKE, we've just published a lot of content on Portworx. So just go to the Portworx blog, and you'll find the Rancher blogs right there up at the. It gives you more specific details around MySQL, Postgres, and MongoDB, and we'll have Cassandra and Kafka coming in the next couple of days.
Wonderful. Thank you very much, Michael.
Thank you, everyone. Have a great day.
Bye-bye.